So, this is 4.4, the fundamental, oh, it's blurry. It's because of this part of the screen. I got it. Okay. The fundamental theorem of calculus. Alright? I think you guys get an extra credit point for thinking up me recording these.
Is this like a lot less like important than it sounds like?
No, it's probably the most important thing. Yeah. Hey, you can't have extra topping when we're recording. Okay, here we go. Fundamental theorem of calculus. So, the fundamental theorem of calculus says that if f of x is continuous, what does continuous mean?
No holes, kings, gaps.
No holes, kings, gaps. But let's like remember for like old school sake, f of c exists. The limit from the left equals the limit from the right. I know, it's blurry. It's been struggling today. Hold on. Okay. And therefore that has a limit, right? And then we would need for the limit equal the value. So pretty much it's a continuous function. Now, somebody first period had a really good question. They asked, do I have to check every single time that a function is continuous when I do that? No. Okay? We are going to assume that all of our functions are continuous. Okay? Now, if on the IU test they throw me a question and I see it and I'm like, oh no, I need to go back and we need to talk through it and understand a proof, then we would do that. Okay? That would be more of a proof thing. Does that make sense? Okay? Alright. So it's continuous on a closed interval, AB. And now this notation is important. Big F of x is an antiderivative. So that means we can take the antiderivative of it. Okay? Of little f of x. So when we integrate, we go from little to big. Okay? That's a big notation thing. Okay? Then, here's the big deal. Dun dun dun. The integral from a to b, see we have limits of integration now, of f of x dx equals big F of x from a to b, which equals f of b minus f of a. So, this just says I can integrate my function, put in my limits, and subtract. That's it. Oh, that's just, okay, so once I integrate, we take the squiggle and we turn it into a line so that we know that we need to plug things in. It's more of a notation thing than it's to help you remember you need to plug in, but also for those of us who are going to journey on to Calc 2 and Calc 3, you're going to end up having double and triple integrals, and so that you know where you are in integration, you know what to put in. Does that make sense? So it's more of a notation thing, yeah. This is the short way of Raman sums, okay? So you know those long eyes things we were doing? This is the shortcut, okay? So here we go. Example 1. Evaluate so a integral from 1 to 2 of x squared minus 3 dx. So, step 1, take antiderivative. Your antiderivatives were really great on the test besides the trait. You need to brush up on your trait. Alright, here we go. X cubed over 3 minus 3x. No C. No C because I have limits of integration now. You know what the end result's going to be. And I'm going to evaluate that from 1 to 2. So step 2, plug in B and A, and you want to do f of B minus f of A. So remember, this goes from A to B, so B is on top. So here we go. 2 cubed over 3 minus 3 times 2 minus 1 cubed over 3 minus 3 times 1. That equals 8/3 minus 6 minus 1/3 minus 3. That equals 8/3 minus 18/3. Does everybody understand the 18/3? Common denominators? Okay. No calculator on this test. I meant to say that. This next test will be a absolutely no calculator. Minus 1/3 minus 9/3. So let's get our fractions in order. Equals negative 10/3 minus negative 8/3, which equals negative 2/3. Yep. All right, let's do another example. I'm not ready to move on yet either. So any questions about A? Yes, I do. Antiderivative and integral are the same thing, but antiderivative talks about more with that plus C, and integral talks more about having limits, an area under the curve and getting an answer or a value. Okay? Does that make sense? Okay. All right. Here we go. The next one. So B is the integral from 1 to 4 of 3 times the square root of dx. So with these, you really want to start moving your constants out front and saving them for later, because what's going to happen is they're going to start getting messy. So when we evaluate this, you want to do 3 integral from 1 to 4 x to the half dx. So now we can integrate, take the antiderivative, 3 times x to the 3 halves over 3 halves from 1 to 4. I was very impressed on your test. A lot of you switched this very well. So dividing by 3/2 is the same as multiplying by what? 2/3. So we get 6x to the 3/2 over 3 from 1 to 4. So that just reduces to 2x to the 3/2 from 1 to 4. So now I can just plug in 4 and 1, right? Okay, so I'm going to go over here and do that. So 2 times 4 to the 3/2 minus 2 times 1 to the 3/2. Now, remember 3/2 is the same as the square root of the number cubed. Okay? So 2 square root of 4 cubed minus 2 square root of 1 cubed. So square root of 4 is 2. 2 cubed is 8. Or you could do 4 cubed first, right? And that would be 64, and the square root of 64 is 8. You remember I said it doesn't matter how you do it. Both ways work. 16 minus 2 is 14. Yes?
Wait, you took the square root of 4 and then you cubed it?
And then you cube it. Yep. It's the same as cubing then square rooting. You could do either one. 14 is the answer. Okay, questions about just straight antiderivative or straight integrals, f of b minus f of a. So the only thing that's hard here again is the algebra. Okay? That's the thing that's going to get you, is those rational numbers, like the fractional things, your fractions, roots, your brain. Okay. The only way they could word this differently is in a word problem. And they would say, so this is example 2. And they could say evaluate, or no, example 2 says use the definition. Use the fundamental theorem of calculus. Blurry. There we go. Use the fundamental theorem of calculus to find the area bounded by the graph of y equals 2x squared minus 3x plus 2, the x-axis, x equals 0, and x equals 2. So that's a whole lot of words. Exactly. So that is a whole lot of words to just do the integral from 0 to 2. And how you know is the smaller number always goes on bottom, the larger number always goes on top. You throw your function. This is your function. I have speech therapy in a couple of weeks. It's all good. Dx. Now we integrate. So take the antiderivative. 2x cubed over 3 minus 3x squared over 2 plus 2x. Are we okay with that antiderivative? And we're going to evaluate it from 0 to 2. Alright, now we just plug in. So f of b now I'm going to be nice. Do I need to plug in the zeros? No, because what is it going to be? You can just show me that it's 0. Okay? That's exactly what you can do. Just show me that it's 0. And if it's in front, show me that 0 in front so you don't forget to make it like a minus. Okay? Alright, here we go. 8 times 2, 16 over 3, minus 6 plus 4. 16 over 3 minus 18 over 3 plus 12 over 3. So 16 minus 18 is 2 over 3. 10 over 3. Yep, 10 over 3. Okay, that's it. That's all I got. So your homework is numbers 1 through 14 in the packet. And the back problems are trig. If you need to know, you need to review your trig integrals. Okay? The trig works the same way. Okay? And so that means you need to know your unit circle for the next test. And that's in 2 weeks from today. Okay?
March